And while he's looking at that, just to remind everybody to go ahead and start filling out your surveys if you haven't started already for the raffles for the stuff today, which will be announced later this afternoon. All right, appreciate it, thanks. Good to go?
Good to go.
Great, Michael.
All right, I'm Mike Thompson. I'm from Argonne National Lab. I am here, well, I'm here to talk about a study that was done by us in conjunction with the Department of Homeland Security. I want to emphasize at the beginning that I'm not here representing DHS, and I'm only sort of marginally representing Argonne National Lab. I really like to say that I'm here as sort of somebody who's really interested in internet infrastructure, and I have the lucky opportunity to have the right background and be in the right place at the right time to help the federal government kind of wrap their heads around the transition from looking at primarily physical infrastructure to sort of what they're calling cyber infrastructure. You'll forgive me for using the word cyber. It's used really pretty universally in the federal government, and so there's no sort of avoiding it. So we did this study in conjunction with what's called the Regional Resiliency Assessment Program. Essentially, this program looks at areas of regional critical infrastructure and sort of the resilience of that infrastructure and its ability to react to failures, to disaster events, et cetera. And so as part of this, this happens every year. They do 10 to 15 of these projects. In 2015, one of the projects that they looked at was the data center and network infrastructure in Ashburn, Virginia. So I presented sort of the intro to this at NANOG in San Antonio in 2014. This is kind of the follow-up. We're done with the first year of the study. I'm gonna just kind of go over a few of the high-level findings, and then I have a bunch of brochures here. If anybody wants to know more, I encourage you to come and talk to me after the talk. We're gonna be doing an official outbrief to stakeholders in July, and then proceeding into implementation activities. So this is the study footprint that we looked at. Most of you know the history of the Ashburn area, essentially going back to May East. It's been a huge hub of internet traffic, thanks largely to that history, as well as cheap power and a very unique set of people in the Loudoun County Office of Economic Development. There's been continued growth in the Ashburn area, such that there's been a lot of projections that last year or this year, Ashburn will be the largest data center market in the world. So for that reason, we're very interested in the effects of a physical event in the Ashburn area and how that might cascade into the internet and into critical infrastructure dependencies that rely on data and network services, both within the region and nationally and globally. As many of the people in this room know, some of the properties that make internet infrastructure so resilient, the fact that it's distributed amongst many different companies, the fact that TCP is so resilient, these properties also make it really hard to gather hard data on this. And also, I bring up the elephant in the room, or the elephant that was in the room through many of our conversations. All of this infrastructure is owned by private companies, and especially right now, a lot of the private companies are pretty reluctant to share information with the federal government, which I think is totally understandable. But I want to emphasize that this program that we did this study under and that we'll be continuing to operate under is totally non-regulatory. And we have offered and will continue to offer to participants PCII data protection, which allows you to share information in such a way that it's not able to be used for regulation, not able to be FOIA-able, et cetera. So we're trying to look at everyone's best interests, trying to look at protecting the resilience of this infrastructure and really sort of revealing some of the infrastructure to lawmakers, et cetera, so that they understand it better, right? So our sort of high-level findings, we looked at IXPs a lot. Most of us know there's a pretty huge IXP in the Ashburn area that we won't name the name of, but there's a lot of concerns that if that IXP were to go down, there would be some serious consequences to internet infrastructure, possibly as global slowdowns, et cetera, but especially looking at locally homed content within the Ashburn, Virginia region. So as we conducted this study, somebody brought up this great analogy of looking at a centralized IXP as sort of a major airport hub. Basically thinking about the effects to global internet traffic if an IXP went down as similar to if O'Hare, stopped being able to route traffic. It wouldn't stop air traffic everywhere else in the world, but that outage would have sort of ripple effects to other airports. And so we kind of used that metaphor and continued on with that as a way to describe to some of our stakeholders what an IXP outage would look like. What we'd really like to do as part of the implementation phase of this project is get some of the right participants in the room to do a tabletop exercise where we look at the outage of an IXP, or even better, do a data-driven approach where some people can share some historical data and we can make some conclusions about what an outage to a major centralized IXP like this would look like to larger internet traffic. Transparency in network and data center infrastructure would enhance resilience planning. One of the big things that came up, and most of our data came out of facilitated discussions, tabletop kind of exercises, and interviews with providers. And one of the issues that came up over and over again is during a disaster event, data centers and particularly content providers may have resources that they can lend to disaster recovery options. They don't have any easy way to contribute to those. And one of their big concerns is having a fuel truck rerouted away from a data center to something like a hospital or an energy provider that may depend on services within that data center. Those dependencies aren't well understood by virtually anyone, and we would like to sort of start asking the right questions to see how we can talk about those dependencies in a way that doesn't compromise IP, but that still allows disaster recovery efforts to really focus on the most important elements without sort of taking down a data center that 911 may depend on or something like that. So increasing transparency, really we'd like to see a workshop conducted where we can get the right people in the room to talk about these issues and sort of decide what the next steps would be and how we can really gather data in a way that everyone is comfortable with. Another big issue that came up is local law enforcement in the Ashburn area, but I would assume that this is generally true across the country. They really don't have the proper training to know how to look for suspicious activity around fiber vaults, around basically any of this sort of internet infrastructure. And this, obviously has to do, this is a very complicated issue. We look at things like credentialing, but a big part of the issue that would help is even if law enforcement had access to fiber routes, et cetera, being able to know, hey, this is a place that we should be looking for suspicious activity on a regular basis. And this, this comes up as a very relevant threat in response to events that have happened in the Bay Area in the last several years. There have been major fiber cuts that have been malicious in nature, and it's very hard for law enforcement to track these things down after they happen. So this is something I think that's going to come up again and again, and really, I'm running low on time, but I want to emphasize as part of these findings, my personal interest, again, not representing DHS, but I think there's a lot that this community can do to get ahead of these issues, to come to the federal government and say, hey, here's what we're doing to improve this, here's what we're doing to make sure that your infrastructure is resilient. And that's really what we're looking for from these sorts of studies. And last but not least, and there are many more findings in this that I'm happy to share with anyone, but data center and content providers may not have a pathway to contribute to resilience efforts and or communicate criticality during an emergency. And sort of the previous findings that I've discussed point to this as well. Basically, if you're a telecom provider, you have a seat at the NKIC on the comms ISAC, and that's a great pathway into disaster recovery efforts. If you are a real estate data center, colo, you may not have that same kind of access, and especially for content providers. And we'd like to help facilitate, find a way to make that feature parity, right? Make sure that content provider data centers and co-located data centers have that same sort of access, and that we're really trying to capture dependencies in a way that's consistent with the way that we use network and data services these days. That's the short and long. I'm going to save questions until the end, but if anyone wants to know more information, like I say, I have a bunch of these brochures, and I'd be happy to share my contact information or chat with you in more depth. And I want to thank the NANOG PC for letting me do this short talk. Thanks a lot.
Thanks, Michael. Thanks, Michael. Good stuff. Appreciate it. Thank you very much. Next up, Paul, you're right here. On time. All right. I want you there. Yep. I am. Next up is Phil Roberts talking about his CrypTech update for cryptology.
Right. I think I hit the wrong button. Sorry. That is the right button. Yeah, the big green button. Hi, I'm Phil Roberts. I work for the Internet Society, but I'm here to talk about the CrypTech project. CrypTech is an open source community project. It's been going for a couple of years, and I want to give you an update that tells you something about what it is, why you should care about it, where it is in terms of its current status, things that we are looking for. In particular, I'm here looking for people who are interested in participating in our alpha tester program and other ways that you might be able to help. So CrypTech, what is it? CrypTech is an open source hardware security module project. It is open source hardware and software. Hardware security modules, if you know what they are, then you can check out for a little bit. If you don't, people who have a need to protect very critical secrets, typically keys, use hardware security modules to do that. They're used in key internet infrastructure. In particular, we're interested in things like DNSSEC and RPKI. It's a hardware device. They are sometimes standalone devices. They're sometimes cards riding on a server. They have a wide range of uses. The ones in particular that we're interested in, like I said, are DNSSEC and RPKI, things that are important for the ongoing operation of critical internet infrastructure. Why should you care about it? The CrypTech project was started by a group of people who are very involved in IETF leadership, who were very concerned that there are backdoors built into devices that we depend upon. We know about backdoors in routers, we know about security flaws, and the thought was if we could build an open source HSM, then one piece of the thing that we care about, in particular the keys that we use to secure these things, we could have more assurance and more confidence in. So the project was started to meet that need. It's been moving along. It's been going for close to 2 years, I think, and we have working alpha boards. The engineers got their first alpha boards a couple of months ago, and they have tested all of the critical functionality in them, and they're very pleased to say that everything worked the first time. So we're issuing an order for a bunch more alpha boards for a wider community testing project. The engineers are continuing to do the testing, but I'm actively looking for people who would be interested in helping in deploying these things in their actual working environment. Oh, here's a picture. I forgot to put in a picture. This is a picture of the bottom of the card. This is what it actually looks like. There's an ARM processor and an FPGA, which is the guts of it. This is the top of the card with the cool CrypTech logo. It's a Eurocard form factor. It sits inside a little case that has a pair of USBs that speaks PKCS11, and it has power. If you are involved in DNSSEC operations, I would love to talk to you. If you're involved in RPKI operations, I'd love to talk to you. If you have other uses for HSMs, I would love to talk to you. We know that the first iteration is going to work with DNSSEC. That's kind of what the focus has been on. We expect to have support for RPKI soonish, but we know that there might be other applications for this thing, and if you have an application that you'd be interested in investigating or looking into testing, I would love to talk to you. How else can you help? It's an open source project, so we're always looking for community review. That's a pointer to our wiki where you can find pointers to the repositories. We would like help with testing, we know we need help with documentation, and we're interested in business partnerships, people who would be interested in building an eventual product based on this. So if this is the kind of thing that you work for a company that might be interested in building an open source version of an HSM, I would love to talk to you. And Cryptech is a community project. We're always looking for funding. I'm not really the fundraiser, but if you're interested in funding it, please find me and I will put you in touch with the right people for that. Here's a slide that lists the people who have made it possible so far. All of these people have contributed money, and there are a lot of people who have contributed time and resources to it as well. And that's all I have to say today, so thank you very much.
Thanks, Phil. Appreciate it very much. Next up and final for this lightning talk is Christian. There you are. Nice, Christian. Christian's going to talk about the web of trust.
So, hi. This is a very boring title for an actually halfway interesting presentation, so bear with me. Here we go. So this is a private talk. Whatever you know who I work for, or what kind of company you associate me with, this is completely private. This is also not about the company I will talk about in a second, which is mentioned in the presentation. This is really about, well, us as the community, or certainly about my friends, as you will see in a second, and how we perceive trust and security. So for many years, as many as 3, I'm not on Facebook anymore. I left Facebook and for various reasons, and I told all of my friends about it. And of course they mocked me for it, and you know, half of the parties I'm not invited anymore and stuff like that. So you do what you do, you go back to Facebook. This is the only kitten picture, by the way. So this would be all fine and the conversation would come to an end here if that actually would be really me. Because that's not me. It's neither me nor my account. So someone took the courtesy to create an account and put my name on, downloaded a picture somewhere randomly in the internet, added a couple of informations. Oh, now I actually missed the, oh yeah. Added random informations which were not exactly true, like my hometown, fucking in Austria. Added a cat picture, not exactly my taste either, and invited 20 friends, or at least people from the community he thought they are my friends. This worked very well, and the seed group does whatever they do. They were all happy that I'm back. So, you know, one friend suggests the next one and so on, and suddenly you end up with, by today, 170 of them. And the first 150 were actually reached in like 3 days. So this was a really good bootstrapping process, and it was really fast. So, you know, besides the entertainment value of that, is that actually a problem? I mean, who cares? Just a little bit of identity theft left and right, nothing big. To talk about. The interesting part out of that was that out of these 170, literally 3 of them asked me out of band via text message or email if that is actually my account and why the hell are you coming back? I thought you don't like it anymore. Funny enough, 2 of them actually work for me, so that is a good thing, that at least my own people listen to me. As I have heard about, and I come to the account in a second, 12 people started to chat with that person and asked via Facebook Messenger inbound, is it really you? Where the person then who is owning the account right now said, yeah, sure. So you changed your mind, and the person said, yeah, wanted to come back, and nobody really questioned it too much. Literally no one of the 170. So some of them realized after a while that probably something is dodgy, it's not exactly my style how I react, or it's not my kitten pictures is a little bit strange. But even the one who said afterwards they were suspicious, none of them actually told me. And said, I was suspicious, or, I defriended you again because it looked like fake. I also have, as I was told since yesterday or 2 days ago, a Tinder account now, which is great. So if you want to date me, this is your chance. So, besides the whole Facebook part, as Facebook is used as an authentication for other applications, whenever you actually start trusting that one, you can build on that. And you're not just using it for Facebook, you basically use it for everything else which builds on it. So this little trust in the beginning, where you actually believe this is really the person, and you don't really verify, at the moment where you get enough people, and I talked with various of my friends, so did you not become suspicious? And most times the answer was, well, there were already 50, 100 other people, so, it looked all legitimate. So if you actually get a seed group of a certain amount of people, then getting more and more is actually not particularly difficult. If an account has critical mass, nobody really challenges the validity of it anymore. And all what was needed was my picture. So, so how much do you trust me is now actually how much you trust that account. Because, 170 people, they can't really be wrong. So whatever you would do for me on a WhatsApp, Facebook, or any other method of communication, you would do now for that person. If that is configuring a router session, or giving me some NDA information, telling me your salary, whatever you would do, you would now do for that person, because you're not judging it anymore if it is actually the real Christian or not. And as Facebook is also, or most social medias are also very good in blurring the boundaries between work and private life, as I said, whatever you do for that, for me, you actually do probably over that account as well. So I thought a little bit about the entertaining value. What are you doing with that? Well, you make a lightning talk. I guess we have a box in that, tick in the box. And then I thought, what can you actually do to probably prevent that? And these are random examples. The first example is probably more what could, and again, this is not about Facebook per se, but what could social media or any other part, especially with the ones which are also the back-end authentication and login for other tools, what could they actually do to be sure that you are you, or that at least your friends can trust you and know this is really the real one? Well, I guess you could do what other people do, like PayPal, Airbnb, or so. You can do verification. Sometimes they have IDs, but then it's more done against the end person, right, where you scan your ID and you have face recognition and all that kind of stuff via camera. Or you can just do some out-of-band authentication, like a text, an email, to actually see when you friend someone, is that really the person? Threema, one of the WhatsApp kind clone chat tools, is actually using various levels of authentication. So they do, if you're not authenticated at all, you have a little red dot. If at least email and phone number matches, you get a yellow one. And then if you scan the QR code of the other person physically and stand in front of the person, you get a little green dot. So at least you know how much you can trust that particular friend or that account if that is really the person. So probably this is something which might be interesting for us as a community or for the companies to have a look at. The other part for me, or the lesson I learned, I guess, is now I gotta claim my space. It's a little bit like the domain part. So now to prevent that someone else is me, I have to now go to Facebook and all the others I probably didn't want it to go and create an account, because hijacking is certainly much easier, much more difficult than spoofing and creating a new one. So I probably have to put my flag in now in strategic tools and logins to prevent that someone takes them away. So, lessons learned. I will actually take over that Facebook account. I know who it was, so I will have my login by the next 1 or 2 days. At the moment where the kitten picture disappears, you know it's me again. For the other part, I guess I should spend probably more time with my friends in real life so that they notice faster that this is not me. So if you want to invite me for a drink later on, please do so. Thanks a lot.